So we're starting with proof statements about segment and angle. So we have two-column proofs. Those are the ones we use. We have the proof, which is the logical argument that shows the statement is true. And then we have the various formats, which is the flow chart, the paragraph, or the two-column format. Again, we're going to only use so far, or we're only going to use this one, which is a two-column format, which is a statement on the left, the reason on the right, and on the left under the statements is the given information or the result of applying a known property or fact. And then on the right, which is the reason, we're going to have the explanation for each corresponding statement. Now, acceptable reasons in a proof is the given information. You guys can figure that out, whether it's given to you in a written format or from a diagram. And in order to prove the given statement and the reason and the final thing they want you to prove, you can use definitions, properties, postulates, or theorems, previously proven ones. So far, guys, you guys can only use the ones we have covered. So if we're in chapter 2, you can only use information from chapter 1 and chapter 2. When we get to chapter 3, you can use 1, 2, and 3, because that's what you know. Also, I want to point out, geometry is cumulative. So you will be using stuff from chapter 1 later down the line. So don't just erase it from your memories. It's important for you guys to remember. And I wrote in the top, because I don't think so, because I think so is not an acceptable reason. If you know or you think it's not acceptable, you have to find a way to prove what you guys see in the diagram or what you guys know, using, again, the givens, the definition, properties, postulates, and theorems. Now, a theorem. A theorem is a statement that can be proven. So, proving using deductive reasoning. Right now I'm going to introduce you guys to two new theorems, Theorem 2.1 and Theorem 2.2. Theorem 2.1 is the property of segment congruence. Segment congruence is reflective, symmetric, and transitive. And the 2.2 is properties of angle congruence, which is the congruence is reflective, symmetric, and transitive. I don't know if you guys remember, but we saw this on the last slide. Okay, so as I was saying, we have reflective is the same thing, so DE equals DE. For symmetric, we have DE equals FG. So therefore, then FG equals DE. That is for symmetric. And for the transitive, I'm going to write it in the bottom. So if we can write DE equals FG and FG equals HI, then we have DE equals HI. So I'm just going to circle reflective with this one, symmetric with this one, and I'm going to transitive with this one. Obviously, the same thing applies with the angles, but I just wrote them in letters right now to remind you guys how it looked in the other slide. So this is how you write the theorems 2.1 and 2.2. Again, they use similar letters. So the only difference is this symbol right here and the little lines at the top. You guys have to remember these are segments, so they have to write the line in the top. And just as a reminder, the equal sign with the squiggly means congruent. Also notice that the same thing for the segment applies to the angles. They also have the congruent and they also have the little angle sign. It's important for you guys to put them. Again, reflective, it's equal to itself. Symmetric, it flops. So if it's DE equals FG, then FG equals DE. Same for the angles. If angle A equals angle B or is congruent, then angle B is congruent to angle A. And the transitive applies, like I explained it in the last slide, also to the angles. If angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. So, guys, this is an example. I have scratched out the reasons, but they want us to prove that AC, so they gave us that AC equals AB plus AB. So, just to write it in, they give us this whole thing is equal to AB plus itself. So, in that sense, we notice that B is in the midpoint, because if you add itself and it's the whole segment, then it's obviously in the middle. But we have to prove that AB equals BC. Logically, we can say it is, but we have to go one step at a time. So, we write down the first step of AC equals AB plus AB. That is the given. That is very important. Always start with the given. Now, we see that AB plus BC equals AC. That is a segment addition postulate. You guys have seen it before. Not recently, but I know you've seen it before. So, segment addition postulate, or SAP for short. Now, next we have AB plus AB equals AB plus BC. You guys notice that one of these ACs got substituted by the other? So because, well, I just mentioned that, I gave you guys the answer. So substitution was what happened from step 2 to step 3. And then I want you guys to notice that they subtracted one AB from both sides. So therefore we were left with subtraction at the end. Subtraction property or of equality, or subtraction POE. Let's start. So M is the midpoint of segment AB. If we were to write that out, that means that AM and MB are congruent. They want us to prove that AB, so this whole thing, equals AM plus AM, or 2AM, which makes sense because AM is congruent to MB. Now, we figured out what's going on in the diagram. Let's figure out how to write it in words. And for the first one, you want to write the given, because it's what they give us. M is the midpoint of segment AB. Now, this next one is a definition of a midpoint, which is just the segment AM is congruent to segment MB. Now, without the segment line at the top, that is a definition of a congruent segment. This step you can usually skip if you already wrote the definition of a midpoint on the top. But in this case, since it's written, we're going to use it. Now, to keep going, we have step 4. So from step 3, AM equals MB. We can say that AM plus MB equals AB. Again, because it's a segment, we use the segment addition postulate is what we use, or SAP for short. Now, from step 4 to 5, we're going to use substitution, because as you guys see, this MB disappeared, but we stated up here that MB equals AM, so we're able to substitute it in. Afterward, we just simplify, because we add the two M's together that we have right here into a 2AM equals AB. Therefore, that proves the first part, but they're asking for two proofs, part A and part B. So to get from part A to part B, we divide the property of equality, POE. I wrote division and in parentheses or multiplication, because you can multiply by a fraction, it's the same thing. Alright, so the last step proved the part B. So we're done. We proved both of them. We are good to go. Now this last one it's just an example of what a proof is. So in a proof, you make one statement at a time until you reach the conclusion. Because you make statements based on facts, you're using deductive reasoning. Usually the first statement in recent pair you write is given information. Usually it's going to be always. Now here they tell you that angle 1 is congruent to angle 2. So obviously, if they tell you that this is congruent to this one, it's going to be also true for the opposite. Now, we can't just write that's going to be true for the opposite. We're going to have to write first step the given. So this one right here. Afterwards, we're going to have to write the measure of angle 1 and the measure of angle 2 are congruent. That is the definition of a congruent angle. Then for step 3, we're just going to flip the measure of angle 2 is congruent to the measure of angle 1. It's going to be the symmetric property of equality. And then last, we can just say that angle 2 is congruent to angle 1 because it's a definition of congruent angles.